In this design criteria lesson, we'll be talking about our design specifications. After completing this lesson, you'll be able to understand design requirements, apply critical thinking, and make informed design decisions. A design criteria is an explicit set of goals that a project must achieve in order to be successful. If you're designing a quadcopter like we are, or if you're designing any other product, you're going to have a list of criteria that you need to match. Now, for our case, we're going to be creating a post-disaster search RPA, or remote piloted aircraft. Now, this is the most important thing that we need to fit into. We need to have a vehicle that can go up into the air and view areas that are hard for us to get to. The next thing that we need to fit is ease of transport. That's going to be very important to us when we're creating something that can get into these locations where potentially there's a natural disaster, but it's hard for a human to get into these areas to search for people. So the ease of transport is going to be important because you're not going to want to hike to remote locations or get into these hard to access areas while carrying a large case with you. And lastly, we want to make sure that we have a long flight time. We're going to do everything that we can to optimize our design to increase that flight time. When we talk about our post-disaster search requirements, first and foremost, we need to make sure that we have a live camera feed. We're going to be designing our device to have a live camera color feed, and we have direct control over the tilt of that camera. So we want to be able to hover and look directly down, or we want to be able to have the camera forward as we fly so we can see where we're going and also look into different areas. The next thing that we want to design for is protected components. Because we are looking at a post-disaster drone, we might have down tree limbs, or we might have to fly into buildings where there is potential debris. We want to make sure that we do our best to protect all the components, the propellers and motors, as well as all the electronics and batteries. This is going to be important because we don't want to instantly crash the vehicle and have to recover it or repair it if we run into a wall or a tree limb as we're trying to fly into an area. We want to make this device fast and maneuverable. Now, it's going to be important that we have a long flight time, but it's also going to be important that we can get up into the air quickly and that we can get into areas quickly as well. And lastly, we want to make sure that we have the ability to customize. Now, currently we're planning for a color camera that we can tilt, but we might also want to include a thermal imaging camera. We might want to add GPS location so that we know exactly where it is, whether it crashes or whether we're just looking over areas that might be hard to see on a map, but we can get an exact GPS location. When we talk about our ease of transport requirements, we want to make sure that the overall size of our device is as minimal as possible. Now, some of this is going to be driven by components, obviously. We have a certain list of components that we need to include, including the batteries. We know the props that we want to use and the size of the motor, and we'll talk about all those specifics a little bit later. But those are going to drive the overall size of our device. So knowing that the size of the motors, knowing the size of the props, knowing the batteries and all the other components, it's really going to drive the overall shape. But we know that we can keep it as small as possible while fitting into all those different requirements. One thing that is a big variable is the height of our device. We want to keep it as low profile as possible. A lot of the camera drones you see on the market are relatively tall because they have a camera hanging below them, and they have stabilization on the camera, and they have various other components. Now, this is done to keep the weight at a certain location in relation to the props, and again, we'll talk about all that when we plan out our components. But we're going to do our best to keep the size as small as possible and the height as low as possible. Another thing that we want to do to make it easy to transport is keep it fully assembled. There are a lot of devices on the market that have to be assembled once you get them to your location. Because we are marketing or we're going toward a post-disaster drone, we want to make it easy to not only carry it to your location, but also to get it up in the air as quick as possible. Now, this means that we don't want the people to have to put props on the device. We don't want to have to assemble all the different arms of the device. So we want to have it fully assembled so that it's very quick and easy to get it up in the air. We also want to, again, protect components. It goes back to the disaster search drone, but again, it helps with ease of transport. If everything is a nice protected package, we don't have to worry as much about putting it in a case or putting it in a backpack because we know everything is protected. And lastly, I have backpack drone. Now this is sort of a category that's popular now because there are plenty of drones on the market that can fold up and fit into a backpack. So we're going to minimize the size, keep it as low as possible, so that we can get it into roughly the size of a backpack. Next, we want to talk about the long flight time requirements. We're going to start out planning for a minimum of 15 minutes of flight time, and we're going to explore various options to see how we can increase that flight time. It's going to be important that not only it's easy to get to our location and it's quick to get up in the air, but that we can stay up in the air and search for as long as possible. The next thing that we want in terms of our flight time is a good thrust ratio. Now, a thrust ratio is the available thrust in relation to the mass of the vehicle. So for example, if we plan everything out so that we have a maximum of 2,000 gram force of thrust on a 1,000 gram vehicle, we have a 2-to-1 thrust ratio. For fast racing drones or acrobatic drones, you're typically going to see an 8-to-1 or a 10-to-1 ratio. Now we're not going to be going that extreme, but we want to make sure that we have at least a 2.5-to-1 thrust ratio, if not better. The higher that ratio, the quicker it can maneuver, but generally you're going to be drawing more current and you're going to reduce your flight time. So we're going to have to explore our options, and there's going to be some give and take to plan out what our maximum flight time while still keeping it agile enough to get to our areas quickly and maneuver into tight spots. We also want the ability to configure. Now what I mean by configure is be able to change out batteries and not just add new charged batteries, but maybe add a 4-cell battery instead of a 3-cell to increase the voltage. Maybe add longer batteries so that we have a larger amperage capacity. So there are various options that we can explore to configure the batteries and change the flight time. All of these different things will affect not only the flight time, but how much we can add to it in terms of cameras or additional components, and how well it's going to maneuver. So everything is going to be a give and take, whether it's in flight time or size or maneuverability. And these are all things that we're going to take into account when we start planning out our configurations.